hello Challenger. We are here in another weekly live that happens every Tuesday at 10 p.m. London time. And today we're going to be talking about beyond the stack trace, how elite Java developers use active listening to solve complex problems. So let's discuss first the core active listening skills. Actually, before going through this content, let's discuss why this is important. So basically, the more you grow as a Java developer, the more communication skills become important because technical skills will take you up to some point in your career, but the more you grow, the more it will be necessary to do meetings with other teams, and you have to understand what are their necessities. You have to communicate with your team on what are the best approaches, or you have to understand the business, you have to understand the company's problems so that you can solve them in the best way as possible. So your communication skills become more and more important as you grow because the more you grow, you're going to have to write more documentation. You're going to have to tackle problems that are more related to people and specific business problems. So, like even the ability of creating tasks and the ability of working on bigger projects, you're gonna require to have better communication skills. So let's start here talking about core active listening skills. So if you don't know, active listening is one of the most important traits to have good communication skills. So one thing that will help you to show more confidence when you are communicating with someone else is to maintain eye contact during discussions. Why? Because if you deviate your eye contact, you show that you're not confident, you show that you are not sure about what you're saying. So maintaining eye contact is very important during discussions because you're gonna create more trust with people, withholding judgment until full explanation is given. So we can't judge people before they finish their point. So we have to wait for them to give their explanation and then we can expose our idea. Obviously, if you see that the person is saying too much and there is nothing to do with the problem, in some cases you can tell the person politely, but most of the times it's better to wait for them to finish their point. And to be a good listener, and you have to remember that one of the best skills as a leader is to know how to listen. Because if you talk over other people, you're not being a good leader because you are just imposing whatever opinion you have. So you have to resist the urge to mentally solve problems while others are still explaining. And this is very common, right? When someone is saying something, we try to solve the problem before the person finishes their point, and we have to resist this urge of stopping the person in the middle of whatever they are saying. So another good skill when we are communicating to other developers is to paraphrase technical explanations to confirm understanding. So for example, if something from the technical explanation said and you don't understand what's going on, you can repeat the same thing, paraphrasing this technical explanation to see if it's really what you think it is. Because if you don't do that, then if there is a detail in this technical explanation, you might miss it, and in the end, you might have a bug or some problem related to that. And another thing is that you have to note non-verbal cues in technical discussions. So for example, you have to recognize when a developer's furrowed brow indicates confusion despite verbal agreement. And you have to also observe hesitation or hand gestures that suggest unstated concerns about an approach. So basically you have to observe their body language because sometimes they will say something, but their body language will say something else. And obviously, it's more difficult if you're working remotely because then a lot of the body language is lost. Or, for example, detecting enthusiasm through increased animation when discussing certain technical solutions, or noticing when team members they cross arms like that, or which during architectural discussions. So if you see someone crossing their arms like that, they might not agree with what you're saying, or they might have something against it. And also identify when peers repeatedly check documentation while explaining, suggesting uncertainty. So if someone is constantly checking documentation, it means that they don't know much about the subject. So that could be the explanation. And what are the communication challenges specific to Java development? So let's explore some of them here. So sometimes we are talking about frameworks and we think that everyone knows about what we are talking, but sometimes they don't, right? So sometimes developers talk past each other while believing they are aligned, or maybe knowledge transfer becomes insufficient when mentors use framework specific shorthand, and or maybe architectural discussions derail when participants interpret fundamentals concepts differently, or maybe requirements might get misinterpreted when translated through framework specific mental models, or we might have architectural pattern miscommunications. For example, a Java developer might say, hey, might say service, and this service for Java developers will be interpreted as a Spring service class. And while microservice teams might think of an entire deployable application. So we have to be careful with those words and have to make sure our audience will understand whatever we are saying. And repository, they mean something different. For example, a Spring developer, they will understand that it's a repository, it's a JPA repository, and some other audience, they might understand that it's traditional repository pattern. You have to be careful if the person doesn't know about the framework, you have to explain further. Or there might be a cross-team technical translation, or there might be cross-team technical translation issues. For example, a data engineering team reports we need to optimize the consumer parallelism, while the application team interprets this is a thread management rather than Kafka consumer group configuration. So depending on the context and depending on the team you're working with, they might not understand exactly what you're saying. So you have to be careful. If you're talking to developers, talking about threads, they will understand, but another team might interpret this information as something related to Kafka. So for DevOps engineers, they might say, hey, the artifact promotion failed in the pipeline. The developers might understand that the build failed, which has nothing to do with the problem. So information gets easily lost when we are working across teams. So you have to be careful with that. And sometimes remote collaboration listening, we have some listening difficulties when working remotely because, for example, we miss the visual feedback. For example, a junior developer nods politely during a complex explanation of Java memory models while completely something that would be evident in person through confused expressions. So sometimes the junior developer will nod politely and you think that the junior is understanding the concepts, but they are not. So we could easily get those body kills to understand that the person is really not understanding anything. Or it might happen that team members miss a senior developers when a problematic implementation approach is suggested, leading the team to pursue a solution with known pitfalls. Yeah, sometimes the senior developer is not very forward. Obviously, it depends on the senior developer because if the senior developer is minimally professional, they would say, hey, this will happen. If we do that, we're going to have those issues. Obviously, like in some situations, like even though we might miss some specific thing happening with the body language of the senior developer, the right thing for the senior developer to do is to say, to talk about the problem. Or it could happen that an architect excitement, or we could have the situation where an architect's excitement about a particularly elegant solution goes unnoticed because their enthusiast hand gestures aren't visible on the video call. So yeah, those things most of the times they wouldn't be a problem, but they could be. If you're not aware of the body language of people when working remotely, like we might have some issues, but in the situation of the senior developer, the minimum they could do is to let people know about the issue. And sometimes in the communication, we have experience level communication gaps. So, for example, you might recommend refactor this using streams without providing guidance, leading to a junior creating unreadable nested lambda expressions that are difficult to maintain. Or, for example, an architect casually mentions, make sure this is thread safe without specifying synchronization. And this could result that a junior developer would be overusing synchronized blocks and the junior developer could be creating performance bottlenecks. So there could be some issues. And code reviews is also important, right? So we need to use active listening skills during code reviews because code in the end is the pride of developers, all right? So we have to be careful in the way we give feedback about their code. So before asking, hey, why are you doing this? Why are you creating this bad code here? You can ask about the intent because sometimes the developer has to do something that's not pretty, but maybe there is a reason behind the scenes. So ask the intention of the code before the implementation, before criticizing them. Also separate stylistic preferences from technical concerns. So for example, if the person forgot like a small space or if there is a small detail about code style, this is just a minor review and it's always better to separate the style review from the more important technical aspects of the code. And we also have to invite elaboration on complex implementations. So for example, if a developer wrote a very complicated code and there is more than 10,000 lines of code, like it's good if the developer could give at least a context on why he or she created this kind of code. It's a good practice to explain your own code. So if you create a pull request, just give some explanation about the code because then people can understand it more quickly. And also summarize feedback before responding. Don't write a full article for developers during the code review unless it's necessary, but most times it's not necessary to write a full article. Like be succinct and be direct and make your point concisely. Otherwise, it's usually lots of words that don't help much. And so you waste your time and the reader from the code review will also waste their time. And acknowledge valid perspectives even when disagreeing. So sometimes there will be disagreements during the code review, and that's okay. Like the only thing you can do is to sometimes agree to disagree. And it's important that instead of clashing too much about an idea in the code review, sometimes it's wiser to just accept and keep going because there's a lot of work to finish and you can't waste time on review comment. And also, one thing that's wise during those conversations on code review is to pick your fight because sometimes it's something so small someone else suggested to you that it's not worth it, the fight. But if you see that it's worth it to keep the code the way it is, then okay, pick the fight, and obviously be polite with the other person, explain why this code is important. But yeah, most of the times it's not worth it to go into a discussion and explain the whole thing. Sometimes you have to agree to disagree. And another thing about how elite Java developers use active listening to solve complex problems is debugging conversations. And this section is a bit big. Developers fully describe symptoms. So basically, you allow developers to describe the symptoms and the problem. Don't ask questions while they are explaining everything about the symptoms. Create space for rubber duck debugging. So sometimes talking to a rubber duck about the problems you're facing will be enough to solve the problem because when you explain the problem to someone else, sometimes you have an insight and you solve the problem. And also try using what questions before why questions. So why should we avoid why questions? Because why questions are confrontational. And when you say that, people will be mostly on the defensive. So they will be more reluctant to give you the information, and it will create an unnecessary conflict. So, and it won't help both of you. So instead of using why, use what questions, because that will help them to feel neutral. And it's more, so when you ask what, it's more of a fact finding. So you could ask, for example, what approach did you take here? And by using questions like what, you're going to also create a blame-free environment where developers can share details without feeling judged. Questions examples. So for example, you could say, what did you observe when running the code? Or you could say, what were you trying to accomplish? And this will identify the intended outcome. So you could also say, after those questions, with what? And then when you have a better context, more information, then you could say, why do you think this is happening? Then it becomes more productive. Then using why after you did many questions with what, then you are not so confrontational. And when you ask why, it's going to be also more productive because the person won't to be on the defensive mode anymore. And it's also good to confirm reproduction steps before suggesting fixes because you have to understand all the steps from the bug. Otherwise, how can you even suggest fixes if you don't even know how the problem happens, if you don't have enough information? And also acknowledging frustration without minimizing issues. So, like sometimes the developer is highly frustrated with a bug, and the senior developer might say, hey, it's not a big deal. And this might invalidate the developer's experience with the issue. Or someone might say also, oh, just try X, and then jumps to solutions without acknowledging the emotional impact of the developer. Or someone might say, oh, everyone deals with bugs. And then like it generalizes away specific frustration. So basically, when someone is facing a bug that it's being frustrating, it's being annoying, like don't underestimate the bug. Don't say, oh, it's not a big deal or whatever, because if you do that, in other words, you might be saying to the other developer, oh, you are incompetent, or you are invalidating their frustration feeling. So be careful in the way you say that, because at least try to acknowledge the frustration. And another important point is about client requirement clarification. So it's important to distinguish between essential and preferred requirements. So for example, if you're talking about performance requirements, so the essential could be the transaction must complete within 2 seconds to meet payment processor timeout limits. And a preferred requirement could be the dashboard should load within 1 second for optimal user experience. So we have to focus on the essential because that's the business need. Identifying spoken technical constraints. So let's see one example here from legacy system integration requirements. So there could be an unspoken constraint, like our new Java microservice must integrate with a 15-year-old ERP system that only supports SOAP with specific web services with specific WS security headers. And how it surfaces. A stakeholder casually mentions, this will connect to our ecosystem just like everything else, without mentioning the legacy protocols. So if we are to use an active listening technique here, we could ask, could you walk me through all the systems this will interact with and their integration methods? Are there any existing integration patterns we need to maintain? So make more specific questions. Don't just accept the information, because if you get an information and you don't understand it, you have to make sure that you make the right questions. You have to investigate and confirm business logic. So let's see the example of discount application roles. So the requirement here is that customers should get discounts based on their loyalty tier. An ineffective confirmation could be, I will implement the discount system based on customer tiers. Now, an effective confirmation could be, I would like to confirm how these discount rules interact. Then you could ask, for example, if a gold tier customer uses a promotion code, or if does their tier discount stack with the promotion. Or you could also ask if their tier discount stack with the promotion as well. Or you could ask when calculating the final price, at what point is the discount applied, before or after tax. So the more question you ask, the more detail you collect, the better. And also explore edge cases through questions, because if you don't do that, you might be also judged that you're not experienced enough. So asking about edge case scenario is very important. So you could ask, for example, what happens if a user attempts to register with an email that's already in your system? Or you could say, should we allow registration from disposable email domains like tempmail.com? Or another example could be, what's our minimum password strength requirement? Do we enforce it client side, server side, or both? So basically check those edge case scenarios and don't start implementing something if you don't have the full information. And there might be issues as well on cross-functional team listening. So let's explore this one. For example, when translating product management needs into technical requirements. So the product manager could say, users are complaining that the dashboard is slow. We need to make it snappier. Part translation could be optimize the dashboard's code to make it faster. And the needs developer translation would be implement Redis caching layer for frequently accessed dashboard metrics within 5 minutes TTL. Another one could be refactor dashboard APIs to support progressive loading pattern with initial metrics loading in less than 500 milliseconds. Another thing could be to add database indexes on the fields used in the 3 most common dashboard queues. The other thing could be implement front-end virtualization for large data tables to reduce DOM manipulation. Another thing could be to add server-side pagination with configurable page sizes for all dashboard data grids. The last point is to establish concrete performance. SLA, initial load under 1.5 seconds, subsequent interactions under 300 milliseconds. So that would be an analyst developer translation. So you see, there's a lot more depth and a lot more knowledge on performance and components. So this is a difference between an elite developer and an average developer. Like it is to create a task, to create a story with this information is almost impossible. But with this, like it's a lot easier, right? You can create a story for that, can create another story for that, another story for that point, another story for this, another story for the pagination. It's a lot easier to delegate this work to another developer, right? So that's how communication really changes the game. And the more you grow as a developer, the more communication becomes important, because the more you grow, the less code you're going to do, and the more you're going to delegate, the more you're going to make technical decisions that are important that might impact the whole company. And you have to know how to talk about this change, how to talk about this technical change to everyone. And sometimes you have to bridge UX concerns with Java implementation realities, or capturing key insights for improved test coverage, or you might have to extract useful context from DevOps feedback. And you can also advance your career through listening. So how can you do that? So one of them is to build a reputation as a collaborative problem solver. Another important point is to reduce rework through improved initial understanding. For example, in the payment module, a developer receives requirements to build a payment processing service supporting credit cards. They implement the solution using Stripe's API, handling card, validating, charging, and refunds. After review, they discover the business actually needed support for both credit cards and ACH bank transfers, require significant rework of the payment processor abstraction. Then the investigation reviews the need for an extensible payment strategy pattern supporting multiple payment types. The developer would create a payment processor interface. They would implement strategies for both credit and ACH processing. And the outcome is that the solution requires no architecture changes when PayPal integration is requested 3 months later. and when international payment methods are added in the following year. And another way to improve your career through better communication skills and active listening is to mentor junior developers with empathetic listening. So how can you do that? Like sometimes the junior developer don't know something very basic, but you have to remember that you were a junior developer as well one day. And like in the past, you also didn't know something very basic. So being empathetic with the junior developer and understand that they are on their way to become better. And regarding improving architectural discussions with stakeholders, so be aware that people from business won't understand the technical jargon. So pay attention to whom you are talking with so that you can improve the way you communicate. And also think about converting listening insights into technical leadership. Basically, the more you communicate clearly to people, the more you get recognized and the more chances you get to be promoted and also become a reference a lot more easy. And that's pretty much it, Java Challenger. I very happy that you are here, investing your time to improve your career. And that's pretty much it for today. And remember that every Tuesday at 10 p.m. on time, I'll be here talking about something important for your career, about what actions you can take to improve as a Java developer and get access to the best jobs and also to increase your salary. So thank you very much, Java Challenger, and I'll see you the next time.